This is a tutorial for the simulation called Harmonics in Instruments. And this is a simulation that I show after we talk about standing waves and how the different harmonics add together, which is something I showed when I demonstrated this simulation. So if we click in here, it's really just a longitudinal wave at the top showing the actual sound wave, as well as a transverse representation at the bottom. And so if you like, whatever the instrument is, this red bar here would represent whatever is creating those sound vibrations, whether it's the string of the violin vibrating or whether it's the reed of, let's say, a clarinet vibrating. And the first thing you can do is you can adjust the amplitude of different harmonics and add them together. So you can get all sorts of weird things. Maybe this is a little hard to look at. I'll reset it. But if you, for example, just show the first and second harmonic, you can see them as the green and red in the transverse wave representation below, and the blue as the net, as well as the longitudinal wave representation at the top. And I made this just to show the addition of different harmonics. Now, I don't actually remember what resource I used to get these values, but this represents the harmonic structure of the sound from an alto sax. Again, I'm not 100% sure how accurate this is, but I did get these numbers from somewhere years ago when I made the simulation. What's interesting is if you click on flute, which is a relatively clean sound, you actually get a very clear harmonic structure as well. You get a lot of first and second harmonics, but not much of the third, fourth, fifth, sixth, and seventh. Violin, of course, is a very rich, complicated sound, so we get a very complicated harmonic structure, as is a clarinet. We get all sorts of weird harmonics adding together in strange ways. You can also zoom in onto the wave if you like, and you can see we've got this very large compression matching up with this very large peak in air pressure in the transverse wave. The other thing that you can show, aside from the different waveforms and instruments, is you can actually show acoustic beats in this simulation. I already showed how to demonstrate those in the previous simulation, wave interference in 1D, but you can also show it here if you like. So if we pick two waves that are close in frequency, like the 9th and 10th harmonic, and if we just zoom in here on the transverse wave representation, you can see a great representation of the blue being, of course, the net wave, when you look at how it adds constructively and destructively to create those acoustic beats. And if you look at the longitudinal wave above, you can see clear compressions and rarefactions when the amplitude is larger and less distinct differences when the amplitude is smaller. And that's how I use this simulation. I hope you find it helpful.